Hi there, and welcome back to my Precalculus video series, where my goal is simple: to make Precalculus make sense. Whether you're here to get ahead, catch up, or finally understand what your textbook is really trying to say, you are in the right place. In our last lesson, we explored how addition and subtraction work with real numbers, and the crucial rules for negative signs. If you missed it, don't worry, you can find that video right here. Today we're diving into multiplication and division, especially when fractions are involved. This lesson will clear up common confusion around concepts like multiplying by the reciprocal, dividing by a fraction, and combining fractions correctly. By the end of this video, you'll be able to 1. Understand the multiplicative identity and multiplicative inverse. 2. Multiply and divide real numbers, particularly fractions. 3. Utilize key properties of fractions to simplify and solve. And 4. Add fractions with both like and unlike denominators using the LCD, or least common denominator. Thank you for being here. Now let's get started. Just like 0 is the additive identity for addition, the number 1 is the identity for multiplication. We call it the multiplicative identity. This means that for any real number a, multiplying by 1 does not change its value. So this is the rule. If I have any number a and I multiply it by 1, it'll result in the same value a. Now what about division? Division is simply multiplication by the multiplicative inverse, or what we call the reciprocal. Here's the rule. If a is any non-zero number, then its inverse is 1 divided by a. And when you multiply these two together, you will always get 1. Here's a quick example. If I take 7 and I want to multiply it by something to give me 1, I'm going to multiply by its multiplicative inverse. And the multiplicative inverse is 1 divided by the value of whatever your first number is. So the multiplicative inverse of 7 is 1 over 7, and that will result in a value of 1. So simply put, dividing by a number is the same as multiplying by its reciprocal. If you're used to seeing a divided by b, which is the same thing as a over b, we can write this as a being multiplied by 1 over b. So the standard division operations that you see, like here and here, all that it really is just a different form of multiplication. Let's go through 6 key properties that are essential for multiplying, dividing, and simplifying fractions. Here is our first property on multiplying fractions. Here's the rule. If I have a divided by b and I'm multiplying it by some other fraction, c over d, the result is the product of the numerators, a times c, all in the numerators, a times c, divided by the product of both denominators, b times d. That is our first rule of multiplying fractions. You just multiply straight across in the numerator and straight across in the denominator. So here's an example. If I take 3 over 4 and I multiply it by 1/5, the rules for multiplication of fractions say that I need to multiply the numerators together. 3 times 1 gives me 3, and 4 times 5 will give me 20. So 3/4 times 1/5 gives me 3/20. Here's our second rule on dividing fractions. If I have a divided by b, and I'm dividing this fraction by another fraction, let's say c divided by d, then I can rewrite this division as multiplication. So I can actually multiply a divided by b by the inverse, the second fraction flipped, d over c. So it's easier to do multiplication with fractions because in property number 1, we just multiply across. So what we do is that we change this division problem into a multiplication problem. So let's see an example. Let's say I want to take 2/9 and I want to divide it by 5/3. But what I'm going to do is I'm going to make my life easier. I'm going to think to myself, well, it's too difficult to manage dividing a fraction by fraction, so I'm going to make my life easier and change this into a multiplication problem. And so I do that by rewriting my original fraction, 2/9, but instead of dividing, I'm going to multiply. But if I'm going to switch the division to multiplication, I need to flip this fraction from 5/3 to 3/5. And all that I do is that I use property number 1 to multiply fractions straight across. So 2 times 3 3 is going to be 6. 9 times 5 is going to be 45. So this is our answer, but you can go one step further and you can reduce it to its simplest possible terms. And so I can reduce 6 out of 45 to 2/15 by dividing both the numerator and the denominator by 3. Property number 3 deals with adding like denominators. So if I have a fraction a divided by c and I add to it b over c, then my answer is just going to be a plus b all divided by c in the denominator. So when you have the same denominator, all you do is just add the numerators at the top and you keep the same denominator. So if I have 3/7 and I want to add to it 8/7, well, since the denominators are both 7, that's going to remain the same. And all that I do is that I add 3 plus 8, put it on the top. That is 11 out of 7. Property 4 deals with adding unlike denominators. When you want to add fractions that have unlike denominators, then what you want to do is you want to find the LCD, or least common denominator. Once you do that, then you use property 3 to add the fractions. Here's an example. Let's say I want to add 2/5 and then I want to add 3/7 to that. Well, because the denominators are different, I cannot use property 3 and just add the numerators. And so this creates a problem for me. But what I need to do is that I need to find the least common denominator. And so if you don't know what the least common denominator is, here's one way to think about it. You're going to take each denominator and you're going to find its multiples. So for example, if I start with the number 5, I'm going to find 5 times 1, 5 times 2, 5 times 3, 5 times 4, and so on. So this would be 5, 10, 15, 20. And you're going to do the same thing with the 7. 7 times 1, 7 times 2, 7 times 3, times 4, and so on. And you're going to go until you find an answer that they have in common. 7 times 1 is 7, 14 here, 21, 28. 7 times 5 gives me 35. And if I keep going, 5 times 5, 25, 5 times 6 is 30, and then here 5 times 7 is 35. So here I have found this is the smallest number that they both have in common. So what this means is that I need to convert each fraction here into having a denominator of 35. So that way I can use property 3 and combine these two fractions together. So here's what that looks like. What I'm going to do is that in order to modify the left fraction to have a denominator of 35, I need to multiply the denominator by 7, because 7 times 5 will give me 35. But whatever you do to the bottom, you also have to do to the top, because we cannot change the value. We cannot change the value of this fraction without changing the problem. So I need to multiply both the numerator and the denominator by 7 in order to achieve that denominator of 35. On this right hand side, I need to multiply the numerator and the denominator by 5 in order to get this common denominator of 35. So here's what I really get. 7 times 2 is 14, divided by 7 times 5 is 35, and I'm adding to that 3 times 5, which is 15, divided by 35. Now, by finding a least common denominator, I get a problem just like property number 3. I have the same denominators and different numerators, so all that I do is just add. 14 and 15 will give me 29 divided by 35. And that will be the answer for that example. If that is a bit too tedious, then you can sort of take a shortcut. And it just so happens that in this example, the shortcut was the least common denominator. But what you can do is that you can take the two opposite denominators and then just multiply the opposite fraction by that denominator. So in this part, I multiplied by the opposite denominator, which was a 7. So I multiplied 7 over 7. And then for this fraction, I multiplied by the opposite denominator, which was the 5 over 5. And that way you can automatically always find a least common denominator, but it will not be in simplest terms. If you're more of an efficient thinker, then you can just do that step and use your calculator to simplify whatever answer you get into simplest terms. Here is property 5. Property 5 is about canceling common factors. So if I have a fraction AC over BC, then I can cancel out whatever is shared in the numerator and the denominator to just simplify it to be A over B. So if I have this example, 2 times 5 divided by 3 times 5, I don't need to do 10 over 15. I can see that I have a 5 on top, 5 on bottom. I can create a pair and therefore they cancel out. And I'm just left with 2/3. And here is the last property on cross multiplication. If I have a over b equal to some other fraction, c over d, then the following is true. A times d, these two multiplied, is equal to the opposite two multiplied together, b times c. So a quick example is if I have 3/5 equal to x divided by 10, I can multiply the numbers and or variables that are across from each other. So in this example here, I can cross multiply the 5 and the x to give me 5x, and that's going to be equal to the other two multiplied 3 times 10 to give me 30. And then you can solve algebraically to find your answer by dividing the 5 to the opposite side to give you x equals to 6. And that is cross multiplication. Let's do a few examples. Let's multiply 3/4 and 5/10. When we're multiplying fractions, we just multiply across. 3 times 5 is 15, and 4 times 10 is 40. And then we can simplify by dividing by 5. 15 divided by 5 is going to give me 3. 40 divided by 5 is going to give me 8. So I can reduce 15 over 40 to 3/8. Let's do another example. Now let's go ahead and divide 1/2 divided by 3/4. Well, I can turn this division problem into a problem of multiplication by taking the original 1/2, but instead of dividing, multiplying, but I'm going to flip the second fraction, 4/3. And so 1 times 4 gives me 4, 2 times 3 gives me 6. And I can reduce it to its lowest terms by dividing by 2, finding a factor that they have in common. So here I will reduce it to just be 2/3. Now let's do a slightly trickier example. Let's go ahead and add 7 over 24 plus 5 over 40. Now in doing this, when we added two fractions with different denominators, like in in property number 4, we have to find the least common denominator. But if I do this method, I'm going to take a very long time. So there's a different way that we can approach this. And what we're first going to do is we're going to factor each denominator. We're going to factor 24 and 40, and we're going to find their prime factors. So let's do some side work here. I can create a factorization tree and break down 24 into 2 multiplied with 12. 2 is already a prime number, so I get to stop there. 12 can be 2 times 6. 6 can be 2 times 3. So I've found my prime factorization. 24 is equivalent to 2 times 2 times 2 times 3, or 2 to the 3rd power times 3. I need to do the same thing with 40. 40 can be broken down to 8 times 5. 8 can be broken down to 2 times 4, and 4 can be broken down to 2 times 2. So I found 1, 2, 3, and 4. So this is 2 times 2 times 2 times 5, which is 2 to the 3rd power times 5. Now, we can find the least common denominator by doing this. The least common denominator is found by taking the highest power of each prime factor present in either denominator. So here I have a 2. So I know 2 is shared between the 24 and the 40, but we're going to take the highest power. And since they're both 2 to the 3rd power, I'm just going to take 2 to the 3rd power. I just need one of them. 3 is present when factoring 24. 3 is not present. So 3 is the highest power. The next is 5. 5 is present when we factored out 40. 5 is not present over here, so this 5 is the highest power. So this becomes 8 times 3 times 5, and the least common denominator that I need to achieve is 120. So now I can write my original problem, 7 over 24 plus 5 over 40, and I need to get each denominator to be 120. So for 40, I need to multiply by 3 in the numerator and the denominator. For 24, I need to multiply by 5 in the numerator and the denominator. So here's what this is going to give me. This is going to give me 35 over 120 plus 15 over 120. Then I can, now that I have two common denominators, I can use property number 3 and just add straight across 50 over 120. And we can simplify this to its lowest terms by dividing by 10 and getting 5/12. And that's how we combine fractions, by finding the least common denominator. This keeps your numbers manageable and helps avoid messy arithmetic later on. Let's quickly review what we've covered today. First is the multiplicative identity, which says that any number a multiplied by 1 will always give you a. Second thing is that reciprocals multiply to 1 with the multiplicative inverse. You take any number, you multiply by its reciprocal, 1 divided by that number, you will always return a value of 1. We learned that dividing dividing is the same as multiplying by the reciprocal. So a divided by b is the same thing as a multiplied by 1 over b. We learned 6 important properties of fractions covering multiplication, division, and addition. It's also very good to note that you should always simplify or reduce your fractions if possible. In our next lesson, we're going to explore the real number line in slightly more detail. If you found this video helpful, please like the video and consider subscribing to the channel so that way you don't miss out on any future lessons. Thank you for spending some time with me. I will see you in the next lesson.